Okay, good morning everyone. My name is Mary and today me and Barka are going to talk about capacitive transducers in liquid level sensors. So what is capacitive transducers? To learn more about a capacitive transducer, we first need to know about the basics of parallel plate capacitor. So what is that? It is the simplest form of a capacitor. It has two parallel conducting plates that are separated to each other by a dielectric or insulator with a permittivity of E. So as you can see in this diagram, it is the example of parallel plate capacitor. This is plate 1, this is plate 2, and in the middle is the dielectric separating them. So other than paper, vacuum, and semiconductor depletion region, the most commonly used dielectric is air. We actually have a lot more, but these are the ones that are commonly used. Okay, so how does it work? So due to a potential difference across the conductor, an electric field will develop across the insulator. So like you see earlier, we have two plates, so when there is a potential difference between them, we will develop an electric field. So what does it do? It will cause the positive charges to accumulate on one plate and the negative charges to accumulate on the other one. So the capacitor value is usually denoted by its capacitance, which is measured in farads. So farads is the unit for capacitance. And it can be defined as the ratio of the electric charge on each conductor to the voltage difference between them. Okay, so the value of capacitance can be determined by three things, which is the area of the plates, this one, and then the distance between the plate, this, and then the type of dielectric between the plates, here, between the plate. Capacitive transducers. So how does it work? I will explain this simply first because I will want to go to the formula. So how it works is, as long as there are changes in the liquid, in the level of liquid, there will be changes in the dielectric constant between the plates. So we will go to the formula first before we look more into that. So this is the formula for capacitance. So we have here dielectric constant of the material in the gap. So this one is, it changes with the material that you are using. So if you have air, for example, the value is 1, but if you use water, the value is around 80, like that. So it has a much higher dielectric constant compared to air. So and then we have A, which is the plate area, but what we can also say is the effective overlapping area of the plates. So this refers to the area of capacitor plates that are directly facing each other and can contribute to the electric field. This one is directly proportional to C, so that means if you are overlapping, if you increase the overlapping between the plates, the capacitance will increase. And then you have the permittivity of free space. This one is fixed, so this is the value of this. And then you have D, which is the separation between the plates. This one is inversely proportional to C, so that means if you increase the distance between the plates, you will have a lower capacitance, but if you decrease the separation, you will have a much higher capacitance. So like I said earlier, there are three things that determine the capacitance. So this one, as you can see by the graph, it is directly proportional. So C is directly proportional to A. So if you increase the A, the C will also increase. But if you decrease the A, the C will also decrease. Same goes with delta K. If you change the dielectric constant from a lower value to a higher value, you will have a higher C. But if you change the K from a higher value to a lower value, you will decrease your capacitance. This one, we have delta D, which is the spacing between the plates. So it is inversely proportional to C. So when you increase the value of D, the capacitance will decrease. But if you decrease the value of D, the capacitance will then increase. So back to the the liquid level measurement. How it works is we have two material of dielectric constant. So we have the liquid and we have the air. So this one is the air, this one is the liquid. As you know, the air has a much lower dielectric constant compared to water, which is around 80, and air is 1. So as the liquid level changes, the amount of liquid between the electrodes will change, and consequently the capacitance of the system will change. So for example, if you have an empty tank, the space between the electrodes will be primarily filled with air. So if air, you have a lower capacitance, you have a lower dielectric constant. So what happens when you have a low dielectric constant? You will have a low capacitance. But as you fill more and more water into this, the level of liquid will be higher compared to the air. Okay, like I said earlier, as the liquid fills the tank and rises between the two electrodes, the higher dielectric constant of the liquid will replace the lower dielectric constant of the air. So this will cause the overall capacitance of the system to increase because you have more water than you have air right now. So if you have a full tank, the space between the electrodes are mostly water. So you don't have a lot of air, so what happens is your capacitance will increase. So that is how the liquid level measurement works. So I hope you guys understand. Yeah.